Hi everybody, what we're going to be going through now is just a few examples of the chain rule. So because last lesson we just looked at what the chain rule is and we looked at a very brief example. This time we're going to be looking at a little bit more complicated examples. So I've written up two of them. Now let's have a look at the very first one and let's have a look at why we use the chain rule again. So remember, because you've got content in there and then you have an overall power here on the outside of your bracket, if you can't be bothered expanding that, then it generally means that you're going to be using the chain rule. So let's have a look at using the long method, okay? Because remember, there's a shortcut method and there's a long method. So I just wanted to use the long method for this one. Okay, so y is equal to, now whenever you have a problem like this, you want to make sure that everything's on one level. You don't want fractions in the middle of these brackets. So what I'm going to do is I'm just going to give this equation a little bit of cosmetics and I'm going to move that t upwards. So it's going to change the power to -1. Okay, and that's still to the power of overall 5, okay, because all you've moved is this t. Alright, now what you're going to do is, remember, you're going to have to make a substitution of u or whatever letter you feel like, but we'll stick with u because that's what they have in the textbooks. So let's have a look. T squared minus t to the -1, that's your u value, and then you can say that basically your y is equal to u to the power of 5. Okay, so we've got these two. Remember, that was our first step that we take. The second step that we take in in the chain rule is to achieve the differentials. Okay, so we just need to basically write du. So we differentiate that du over dt, because that's our variable this time. Okay, dt equals to, if you differentiate this, you're going to get 2t to the power of 1 plus t, because -1 times this negative in front gives you a plus, and this power is going to get reduced by 1, so it's actually going to make it -2. Okay, and after you've got this, you can basically adjust it, so you can bring this back down, because you often don't want to leave your power as a negative. Okay, so you bring it down and it'll create this kind of equation. So that's what your du over dt is. Okay, so basically what we have now is we've got du over dt, and what we now have to do also is to differentiate that y value. So y is equal to u to the power 5, so when we differentiate it we get dy over du, okay, equals to, it's very simple, 5u to the power of 4. Okay, so now we have a second differential. Okay, so we have our two differentials, and finally we set up our chain. So we basically have to go dy over du. Sorry, that's not what we're looking for. Remember, last time I asked you to identify what you're looking for. We're trying to differentiate y in terms of t. Excuse me. So basically we're going to figure out dy over dt. Alright, so the way you set this up is you have to use these differentials. So you've got du over dt times by, sorry, I've got a bit of a cold, dy over du. That's the way you set up your chain, okay? So you can basically see that this is true because you can cancel out that differential with that one, and you've got dy over dt as your answer. So let's just use these to substitute it back into there. Okay, so we've got dy over dt equals to this differential here, which is 2t plus 1 over t squared. So that's that one there, and then we use this one here. So we're going to go 5u to the power of 4, and then if you remember what u is from right there, u was the content within the bracket, so we just can replace that now. So dy over dt will give you 2t t plus 1 over t squared times by 5u to the power of 4, so we just plug this in, t squared minus 1 over t. Okay? And that is our answer. Now you can manipulate it into a certain amount of ways, but that's essentially what your answer will be. So I hope you can see that clearly, because it is a little bit of a mess on the board, but you know, that's methods for you. Okay? So that's the answer to the first one. Now the second question, oops, don't want this thing to follow me. Okay, the second question is, you are expressing P in terms of R, so basically you want to differentiate that. So the aim of this particular question is to find the change of P, which is now, it would have been Y, but it's P. So you have to make sure that the differential matches the letters, and the change of R. Okay, so that's what we're trying to find. Again, this is a chain rule example, because basically what we can do is we've got P equal to, now 5 is a constant on the outside, so you just leave 5. This stuff, you're going to first express it as 5 over R cubed minus 2R to the power of a third. And after you've got that power of a third, you move it upwards. So basically you've got R cubed minus 2R to the power of negative a third. Okay, so now that you've got this, what you can do is you can figure out the different derivative. Now I'm going to use the shortcut method in this particular case. So that's going to be dp over dr. I'm just going to leave 5 on the outside, I don't care much about it. Okay, now this shortcut method says that you just take this power downwards, so I'm going to make it minus a third. Differentiate the contents within that bracket, so it's going to become 3r squared minus 2. And then you reduce the power on the overall bracket by 1. So you're basically going to go r cubed minus 2r, and 1 take away that, it's a fraction. So you've got minus a third, take away 3 on 3, which is 1, and you get minus 4 on 3. Okay, so you get that massive equation, and now you can just beautify it, okay? So you want to beautify these kind of equations. So you've got, I can take out the third, so I'm going to make it minus 5 on 3. And then this goes at the top, so it's 3r squared minus 2. And basically this part goes to the bottom because it has negative power. So it's going to go 3r cubed minus 2r to the power of 4 on 3. Okay, so yeah, that can be just, you know, expressed without this, and yeah, that can be expressed like this. Okay, so it really depends on, like, these questions aren't too hard, it's just simplifying it in the end that's pretty tricky sometimes. So yeah, that's the derivative, and that is the answer to the question. I hope you've learned something today, and just keep on going through these YouTube clips, have a look at all the other stuff that I've provided. I hope you have a fantastic day. I'll catch you later. Bye.